Hey, Bogdan here with another video. It's solving quadratics by factoring. So let's dive in. Quick reminder, when solving quadratic equation, make sure that your expression shows ax squared plus bx plus c is equal to 0. With this caveat, a is not equal to 0. So you must at least show ax squared term in order for this equation to be classified as quadratic. So, first example, solving by factoring. So when you have a quadratic equation right in front of you, first thing, perhaps identify, is there a greatest common factor? Now, whether you do it or not, it does not really matter that much, but in the end, it may help you with breaking things down, simplifying it so that you can accomplish your goal. So since this equation shows that the factor 2 is the greatest common factor, we divided 4 by 2, 6 by 2, and negative 10 by 2. So this is why you get inside a new version of that quadratic equation with simpler coefficients. So what do you do with that? Identify coefficient A, B, and C. And then if you remember the process of doing the product first times last, and the sum is equal to 3 when factoring polynomials. So once you refresh that method, you will see that there is nothing more here. The only difference we have, there is a statement that the left side is an expression and the right side is equal to 0. So after we identify what two numbers would multiply to 2 times negative 5 and the same two numbers would add up to 3, we proceed with the decomposition method where you create a statement with 4 terms. Instead of 3, you break that 3 into negative 2 plus 5x. So then we have quickly two groups of 2. You can create those two groups the way you want, but in this beautiful example, we just grab the first last two terms and find a common factor for each group, right? So you'll probably follow the spiel. The first group, 2x is a common factor. You get x minus 1 inside. Second group, 5 is a common factor. You get, again, the same binomial, x minus 1 inside, which tells you that you're on the right track. So moving forward, you take out the new common factor, x minus 1, and then what is left over is 2x plus 5. Since this is a product that is equal to 0, you remember from the previous video that in algebra, the 0 principle is when you have a product equals to 0, either factor of this product must be equal to 0. Could be equal to 0, technically. So either the first or the second, not both at the same time necessarily. So if x minus 1 was equal to 0, then x is equal to positive 1. When 2x plus 5 is equal to 0, solving for x, you move 5 to the opposite side, divide by 2, so you get negative 5 over 2. If you were to substitute 1 back into the original equation, or negative 5 over 2 to the original equation, which I strongly recommend, in both cases you get 0. No other options possible. So now let's talk about another example where, in this case, the greatest common factor strategy does not apply because we have negative 3, 7, and 6. So there's nothing in common here. So we dive in directly into identifying coefficients, A, B, and C. We recall that A, C, and B strategy where you find the product and the sum. And then you break that middle term apart. So negative 2 and 9 would be the only two numbers that would multiply into negative 18 and add to positive 7. So decomposed middle term 7x into negative 2x plus 9x. two groups of 2. Now you understand the process. You're familiar with the process, but you have to say that the left side is equal to 0 because now we are working with equations, right? So you no longer have this polynomial where you have new line, equal sign, etc. Every time you create a new line, you start with the left side and then you insert whatever needs to be there, equals to the right side. Very important. So factoring the first group, negative x is the only factor because between -2 and -3, nothing is in common. So negative x is the one standing. The second group, 9x and 6, gives you only 3. So when you factor inside of each new binomial that you just formed, we have created the same identical binomial 3x plus 2, which is the winning strategy, right? We must get identical binomial for both. So when this is a new factor that is extracted from that statement, then we have 3 minus x. Or you can put negative x plus 3, doesn't really matter. You understand that, the same thing. A plus b is the same thing as b plus a. So the product is equal to 0. That's the key here to understand when solving equation. When two factors multiply into 0, that means one of those two factors, either 3x plus 2 must be equal to 0, or 3 minus x must be equal to 0. Solve each equation separately. Solve the first one to get -2/3. Do not change to a decimal unless you're working with the word problem. And solve the second one by identifying how much is positive x, not negative x. Positive x is equal to 3. Bingo, we have the solutions. That is another example, solving by factoring. The next example, it has fractions, so that looks really scary, but you can still solve it by factoring by identifying the following, that you can extract a fraction and generate non-fraction coefficients by establishing what is the best fraction that would work here. So 4/3, remember 4/3 can be expressed as 2 times 2 divided by 3. So this is why you can say, okay, 2/3 could be extracted from that. So that would leave you 2, coefficient 2 inside. 10 is 2 times 5. So if 2 goes out, then we have only 5 on top, and the 3 was taken out. So no more fractions here. And the second one is really like a magic kind of a step, because from -2 into -3, how is that even possible? If you choose to multiply 2 times -3, you get -6 divided by 3, you get -2. So you must divide it -2 by 2/3 to get -3, or by tweaking what number would be the best number that would give you -2 in the process if you choose to go and multiply that mysterious number times fraction 2/3. So once we have fraction taken out, all of a sudden this beautiful new trinomial becomes a new quadratic equation with coefficients that are whole numbers. So same strategy. Product is equal to 2 times -3. The sum is equal to +5. Find two numbers. Keep in mind that that common factor 2/3 stays with us every single step of the way. You're showing it that it doesn't disappear. So decomposition, quick split 5 into -x plus +6x. And you have two groups of 2, ta-da, and then you factor each group. The common factor here is x. The common factor for the next group is +3. In the process, we get identical binomial, which is a beautiful thing to have 2x minus 1. So let's take it outside. In goes x plus 3, bingo, times 2 over 3 outside. Everything is equal to 0. Now we have 3 factors. A times B times C is equal to 0. That would imply that either one would have to be equal to 0. Since 2 over 3 is not equal to 0, cannot be equal to 0, so you shrink it down to B times A. Instead of A, B, C, you have B and C because A is kind of established that it's non-zero. So this is why you have to work with this product. 2x minus 1 is equal to 0 and x plus 3 is equal to 0. Find the solution for each by solving for x, and bingo, we have the answers. So by replacement of x with positive 1 over 2 back into this equation, you can quickly verify that the left side is equal to 0, therefore is equal to the right side. If you happen to use the second root, the second solution, the second answer to this equation, you get negative 3 squared, then negative 3 here input. When you calculate this left side, it is equal to 0 also. So that's sort of the verification process. Very important for you to go over so that you know that you walk away from your questions knowing it is done correctly. You're not going to assume it looks good. You always want to verify you know it, because we always emphasize that as a secret tool when working in algebra. All right, so thanks for watching this video. Practice questions. So do not walk away and hoping that kind of you know it. Do those questions immediately. Share the video with friends. Comments in the questions below. We'll see you next time. Bye for now.